All right, good afternoon, everybody. I think we can go ahead and get started. Thank you very much for joining us for today's webinar on the regulations on PFAS and what it could mean for the pumping and sealing industry. I am Amy Sisto from the Hydraulic Institute. Today's presentation will last approximately 45 minutes, allowing for 15 minutes of Q&A. In the lower right-hand corner of your presentation window, you will see a chat box. You can submit your questions here at any point, and they will be addressed at the conclusion of the presentation in the order that they were received. Attendees will be permitted to unmute themselves during the Q&A portion at the end, but will remain muted during the presentation. This presentation will be recorded and distributed to all attendees. Additionally, the slide deck will be sent out as a PDF file to all the attendees after the conclusion of the webinar. And a friendly reminder that if you are listening to today's presentation via telephone, please be sure to mute your computer speakers to avoid an echo effect. To speak a little more about the Fluid Sealing Association and Hydraulic Institute and to introduce our presenters and moderator, I would like to welcome HI Technical Director Peter Gaydon. Pete?
Thank you, Amy, for the introduction. So I'm the Technical Director with the Hydraulic Institute, and we are hosting today's webinar to bring information to the fluid handling industry related to regulations on sealing materials. The Hydraulic Institute is the largest association of pump and associated equipment manufacturers and is dedicated to advancing the industry through standards development, training, and advocacy. We are fortunate to have the support of the Fluid Sealing Association, which is a trade association of fluid sealing equipment manufacturers with members in North America, Europe, Central, and South America. They're doing a great job leading the industry by providing important information on the topic of PFAS regulations, which is what we're going to be discussing today. So we've got three great instructors and moderator today. Starting, Ron Frizard is the Global Training Manager with A.W. Chesterton. He has more than 30 years of experience in all aspects of packing and gaskets and is currently the chair of the gasketing division of the Fluid Sealing Association. Phil Mahoney is the Director of Engineering Services, also with A.W. Chesterton. He has more than 30 years of experience with all sealing devices and is a past president of the Fluid Sealing Association. Helping us moderate the session today, Desiree Perry is the General Counsel and Head of Government Affairs at Textiles Coated International. So now I'll hand it over to Phil to go over our outline and kick off the presentation. Thank you, guys.
Thanks, Pete. So before we get too much into the detail here, what the heck is the problem here? PFAS has been a topic of interest for quite some time now. It started a number of years ago, and it's becoming an issue because there's a lot of regulatory, legislative activity to generate regulations around managing PFAS. And the challenge here is that I think what PFAS is, what they're used for, what they do, what their benefit to society is not well understood, and in my estimation, not well reported when you see some articles that talk about it. So our goal today is to actually illustrate what PFAS is and talk a little bit more about that and what the FSA and the HI groups are looking at with respect to PFAS and communicating with as many people as possible about this issue. So I'll leave it to Ron to go through the agenda now.
Yes, hello and welcome everyone. As Phil laid out, we're really going to talk about is more of an awareness of what's going on and how much this issue of PFAS could really affect yourself and your company down the road. So we're going to first talk about what is PFAS and define it. We're then going to talk about the subsets in there, which would be PTFE and fluoroelastomers. And then we're going to also get into like, where do we see all these uses of PTFE and fluoroelastomers? We'll try to give you an idea of what's going on here in the United States and even around the world regarding regulatory issues about regulating PFASs. And then at the end, we really want to talk about what we feel all of our roles are going to be in the next couple of years of where this road is headed with PFAS. So I'll get started, and we're really gonna, when you start to hear from a layman's term of what is a PFAS chemical, we really can get into the molecular chain of a carbon and a fluoride atom and how they come together to make this polymers and other chemical backbones that are used in those type of materials. And there are literally thousands of unique chemicals that can be qualified as a PFAS chemical. As we know, right around now, they have about 4,700 different chemicals, but all you have to do is just add a couple of atoms of other materials to it, and the next thing you know, you got another whole subset that can be uniquely added as also qualify as a PFAS. And as I said, these PFASs all have a unique chemical property and use, and some PFASs, are really essential products. And then we're talking about, are they safe and sustainable and surely irreplaceable? And what you will hear a lot in the news, and it's in the news everywhere right now, it is, matter of fact, it was on our local news here in Massachusetts last night about, a lot of times you'll hear the term PFASs, and you'll hear about a lot of those chemicals, and some of them have a lot of concerns, especially about things like that they, sometimes you'll hear the term forever chemical, because they don't really break down in the environment and they stay together for a long, long time. And they can move through soils and can contaminate drinking water. Once again, that was the local story last night, was local towns that are now testing for water and are picking up more PFASs that are in the water. And they also have this term called bioaccumulation, which is when those chemicals can get into fish and wildlife and even humans and stay in the body. And those are certain things to be concerned about when you're looking at all of those PFAS chemicals and which ones that can have this issue, and actually show, some actually can show to be harmful to people, animals, and all living things.
Ron, this is Desiree. I'm going to step in for just a minute.
Please.
Thanks for the primer on PFAS. I think it's important for us to start this off with a common understanding of basically what we're talking about, what that means chemically, before we get into some of the important nuances of PFAS. I want to ask you, we're hearing some of the talk around PFOA and PFOS, and sometimes a few other chemicals that are of concern. And we certainly see reference to those chemicals and some others in the headlines. But more often than not, it seems like the references in those headlines are to PFAS as a whole. So I thought it might be helpful to the audience if you just talked about the numbers a little bit, even in very rough terms.
I sometimes,
when it comes to chemicals that are of concern, what number or proportion?
I sometimes believe that it's this lack of people being able to pronounce these long chemical names, and being able to just use the catch-all of the word PFAS. Sometimes just a shorthand when people might actually sometimes be talking about those specific chemicals. Like the two that you mentioned, PFOA and PFOS, are two of the most studied and most tested for that could possibly cause harm. So a lot of times when you hear someone talking about PFAS, a large percent of the time they're just talking about those two chemicals. There are also, and when you would want to say how big that list is, here in our state of Massachusetts, just a year ago, they had kind of called it what was called like the PFAS 6 or even the PFAS 8, which would have been like 8 chemicals out of that 4,700 that they are concerned and that there are studies being done. But that's a big number, right, Desiree? We were talking about all of 4,700, and some have not really been looked at. So you could say that out of all those chemicals, they're not used very much, they're not seen very much, and maybe when they do a study that might be an issue. But a chemical compound, like for example, PTFE, has been used for many years, and many studies have been done on it as a finished product like PTFE. So that's where we kind of feel that like adding a finished product that has been used so much for so many things that have not been any issues with, we kind of really think is an important issue here. Anyone who's had surgery in the last couple of years, there's a good chance you have PTFE that was used inside during that surgery. There are people who are walking around with PTFE in their bodies from surgery they've had. There are dental flosses. There are plenty of different materials that are used every day that is a purified material that is still grouped under that PFAS umbrella. So that's our main point. I hope I answered your question well enough.
You did, and what I'm hearing, and I think this is important context, is as of right now, the PFAS chemicals that have been determined to be of concern are really in the single to maybe double digits, which is a very, very small proportion as compared to the whole sort of spectrum of PFAS chemicals, which you've indicated is in the thousands. So why don't we go ahead?
That's a good way. It's a good way to answer it too. Like there's going to be, studies that similar ones that will be studied, and we'll realize that it will have that it has passed this threshold of being detrimental harm. And then there are other things that people just say, well, we'll kind of group them together based on a backbone, you know what I mean? Which really is not the same. That's kind of where we see it.
Thanks, Ron. Why don't we go ahead and move on to what I think will be a very helpful analogy that I think you're going to walk us through.
Well, everyone's been talking about this cat analogy that I was lucky enough to get the idea from actually a paper that was written a few years ago by someone in the science community. And they used it as an analogy to compare this issue about how many issues of these chemicals being of risk. So for example, if you look at all the different felines or all the different cats that are in the world, and if there are 4,000 of them in a room, how many of those cats are really going to be dangerous to you? And once again, it's the same way with PFAS chemicals, right? There are over 4,000 and more if you just easily make a couple of changes, and how many of those are actually dangerous? So compare them. If you go to that next slide for a second there. If you imagined a field of 4,700 felines frolicking in a field, really, a lion and a tiger, those are animals that can really hurt you. They'd be a little bit concerned that they might come and decide to attack you. But of a kitten and, other smaller cats, surely you shouldn't be that upset about. So, it doesn't have to be a special on Netflix with Karen Baskin or anything, but there's a lot of different animals here that we don't really have to worry about. So for us, we're really talking about where this giant field, not all those chemicals are really going to be a problem that have been studied and proven through many years of study to not have any health issues on humans or on animals or in the environment. Would you agree, Desiree? We're in the same path with that? You love that analogy?
Absolutely. And I think it would surprise a lot of people. I mean, people out in the public square to learn that kittens, so to speak, are being lumped in with the mountain lions when it comes to the articles that they read and the statements that are made publicly about PFAS. So I think this is a very helpful analogy. Thank you.
Yeah, and one issue that when you're and this is some people are thinking that like, oh, there hasn't been that much study of this subject. There has been a lot of study for the last really 30 years. There's been studies done on all these chemicals and different types of chemicals and all these issues. And we're really running into issues now where, matter of fact, there was a great scientific paper just written recently about large molecule polymers versus smaller molecule polymers and what those can do to human health. And and that right there breaks down a lot of those PFAS chemicals into different pieces. And this issue about, as I mentioned earlier, this bioavailable, meaning will it be in the material, in the ability to get into someone's body and stay in the body of accumulation. That's, once again, only a small percentage of those chemicals would even have that. So all of those things, that's really a big difference when you say all of PFAS. It's a simple, once again, I think a lot of times when people use the word PFAS, it's more just as a quick way to say, instead of mention these 6 or 8 or 10 chemicals. So it's really like saying, I live here in Worcester, Massachusetts, that you think that I know everybody in Worcester, or that everyone, all hundreds of thousands of people in Worcester are like me, So it's a very differentiation to really kind of group us all together of these chemicals.
Ron, I think you're right. I think that it's just human nature to perhaps boil things down in such a simple way. And so how do you recommend to this group that they, in a very brief way, explain that there are wide differences in that group?
Well, first of all, I'd even go back one step and say, the reason it's important to all of us on this call is it is coming. It is a wave of information overload on this term. You're going to start hearing it everywhere. And we need to be aware of how much it could affect industry today in pumping, for pumps that are using coated, for example, if you got PTFE line pipes or impellers or all kinds of things, in gasketing and in packing for that pump. This is a product that will be clumped, and for no reason, no health or study reason, will be pulled in to the discussion of all of the horrible things that some of these chemicals might cause. So I think the biggest thing that we should be looking at first is more of an awareness of what is coming, and to be able to succinctly tell the differences between these chemicals and this idea of grouping. So I agree with you, Desiree. It's going to be very big when it hits. It's hitting now.
Thank you, Ron. Why don't we go ahead and move on and consider how these differences are important to our collective industries. We'll turn it over to Phil.
Excellent. All right, this is my favorite part of this whole discussion. PFAS chemicals, why should we care about them? I've had this discussion with a number of people, and it is amazing how widely used these materials are. PFAS chemicals are pretty much everywhere in building and construction, infrastructure, aerospace, military, shipping. Every engine room you go to, there's PTFE components in there. Every aircraft landing gear has PTFE components. Fuel systems and hoses use PFAS materials. Batteries, cleaning fluids, solar panels, even microchips. They use PTFE in them specifically because it yields the highest quality in these chips. They need that material to make a chip that's, that does what it's designed and supposed to do. Cell phones, safety equipment, engine compartment wiring. Now, our focus is going to be, it's not just valve, pump, packing, and gasketing. It's actually pumping equipment in general, sealing devices, pumping equipment, piping, expansion joints, a whole litany of material. I think the example I gave when Ron and myself had spoken to, to educate some legislators on this subject, and we basically said, everywhere you look, if you go into a processing plant or industrial area, if you just turn your head, you're going to find something that has a PFAS material in it. It is ubiquitous. And so I'd like to focus in the next slide about one that is probably one of the most important of that subgroup is PTFE. As Ron mentioned, those 6 or 7 chemicals that have been targeted, say in Massachusetts, PTFE is not one of them, but it is a PFAS material. So what is PTFE? It's commonly, polytetrafluoroethylene. We always call it PTFE. That material it's got various trade names, which I won't mention to be fair, but it is ubiquitous. It's everywhere. PTFE is a man-made material. It's strong, waxy. It's a non-flammable synthetic resin with some amazing properties. And frankly, in my estimation and experience in the sealing industry, there are no alternatives for PTFE in a number of applications, which we'll talk about in a little bit more detail in a minute. But PTFE is unique because of its corrosion resistance. It's resistant to corrosion. It's resistant to almost all chemicals. It's easier to list the chemicals that can attack PTFE because there's about 4 of them, in my experience in industrial applications, versus what it can resist. It saves energy because the coefficients of friction of PTFE are one of the lowest of the man-made materials that there are. So the lower the friction in any industrial application, the lower the energy consumed to overcome that friction. It increases safety. Its resistance to all these chemicals makes it safe to apply because, generally speaking, the operator choosing to use a PTFE component is not going to make a mistake with respect to if it's compatible with the fluid or not, right? And it has other implications from a safety perspective. That lower coefficient of friction allows easy movement of machine elements, bearings, a pump packing with a shaft rubbing on the packing. The low coefficient of friction decreases energy consumption, and it allows the shaft to turn with little motion. So you need less power to actually actuate or move the unit when you have PTFE, bearings or seals or things like that. PTFE has been well studied in its finished form. We use it in the sealing devices as an article, right? It's in its finished form, whether it's a filament, a powder. It's used in an elastomer. And it's used in medical devices for years. So it's been well studied and shown no health effects from PTFE in all applications that I'm aware of. So if we could go to the next slide, Desiree.
And Phil, if I may.
Oh yeah, I forgot.
I'd like to just emphasize this last point, that PTFE has been well studied in finished form with no health risks. You've talked about in the prior slide and this one, some of the many ways that PTFE is used in our daily lives and in critical sectors. Can you talk a little bit more about perhaps some examples where PTFE is incorporated in a way that makes this point that there are no health risks, whether it be in the medical space or in the food service space? Are there some examples that you can share with the group that kind of underscore that point?
Oh yeah, in many cases, I'll give the food grade applications as an example, because the medical field, I know it's obviously used in stents, but the qualifications of materials in medical, I'm not well versed on. But I can tell you in the food service type applications, right? In our business, sealing in food grade applications or potable water, right, drinking water, that many cases what's required in the specifications for that equipment is PTFE because it's acceptable for use. It doesn't contaminate the fluids. And it's perfectly safe in its finished form as an article. And that's why you see it used almost ubiquitously in those type of applications as a lining material, a sealant, a sealing device. It's used as a component sealing device. So the stability of it is second to none. And like I said, it's specified many places in plant specs, or there's even, I believe, it's listed in the CFR chapter as being an acceptable material for use in food grade applications. So, and it's been that way for years. It's been used and again for years used as a sealing device. And I've not seen anything in my experience indicating it is not well suited for those tasks.
Thanks, Phil. I think that's really helpful. I know this group is probably eager to move on to talk about PTFE's application and the valve and pump and packing and gasketing space. But before we leave this slide, I got to ask you, what are we looking at here on the right?
So yeah, this is a picture that Ron found, and what you see there is it's one of the many uses that PTFE is used in that roofing component right there. It's massive. I forget I wasn't quite sure what stadium that was, but obviously it's everywhere you look up at a stadium, you're going to see PTFE in use here. And again, it's a PFAS chemical, so when we talk more about the regulatory piece in a couple of minutes, you'll see why this is it's a concern as far as the way the regulations are going. But yeah, this material here, just because of its ability to, it's lightweight, water resistant, lets light in. I mean, there's many other reasons I'm sure they've used it there, but I want to focus a little bit about fluid systems everywhere. Now I'm mentioning PTFE here, but I should also mention there's subcategories to this like fluoroelastomers, which I'll talk about in a bit, right? Because they're ubiquitous, particularly in the pumping industry as well. And so I'm focusing on PTFE here, but I will mention perfluoroelastomers or fluoroelastomers in a minute. So PTFE is used in fluid systems everywhere. And as I mentioned before, there's a lot of good reasons for it. It's unaffected by almost all chemicals, like elemental fluorine, I think is one of its Achilles heels. But other than that, any of the strong oxidizing materials where you can't use other sealing devices or materials like graphites, carbons, certain metallurgies, PTFE is completely resistant to it. It's one of the lowest coefficients of friction with excellent lubrication properties. That's why you see it used in bearings. It's an additive in lube oils. If you look at it as a pump packing, which is what you see in the top left there, that's just packed into a stuffing box within a pump, and it keeps the fluid inside the pump or the valve from leaking out, under pressure onto the out to the environment where we're all walking around and working. So that coefficient of friction, the low coefficient of friction, means that you can run pumps with less power consumption, and that is a big issue with pumps. I know is energy consumption and savings and making the most efficient equipment possible. And in no small part, PTFE can contribute to that. The other thing I would point out is PTFE is one of the best low emission sealing materials in the marketplace. And I'll show you some examples in a second, but we use it a lot in valve sealing technologies, or valve sealing as an example here. And what we're trying to do is keep gases, volatile organic compounds, or toxic materials from leaking into environment from a piping system. The idea is to keep benzene in the system, not let it leak out, or carcinogens or methane. In the old days, the Clean Air Act used to allow for 10,000 parts per million leakage of some of these things. But PTFE-based solutions that are on the market today can seal to single-digit part per million leak rates. So the point being, with the advent or use of PTFE in valve sealing, we can greatly reduce emissions to and increase safety in plants. So we can help you meet regulatory requirements with materials like this, but also make sure everybody in the plant is safe with materials like this. I would point out it's stable to the high temperatures. 500 degrees Fahrenheit typically is given as a safe working limit for PTFE and PTFE-based materials. So it pretty much covers a lot of applications you're going to find in any plant. Now it's used everywhere. Valve and pump packings. I was going to go back one sec, Desiree. I just want to point out where it's well, I'll give you these examples, but gasketing, O-rings for mechanical seals, diaphragms, even liners. You'll see some pumps that are lined or valves that have liners inside with PTFE so that they can use a certain metallurgy and then line it with PTFE and it's chemically resistant. In some cases, if you don't do that, you might have to create a material out of an exotic metal, which is a lot more expensive, especially in larger pieces of equipment. And I also wanted to point out expansion joints. All these pieces of equipment that are in every plant you see use PTFE in some way, shape, or form. Now, this is just going to show you, if we got rid of PTFE, how would that affect us? It's certainly going to say if we can't use PTFE, then these low levels of emissions we get from our equipment today would actually be backsliding, right? If we have to switch materials away from PTFE, our emissions rates would go up, power consumption could go up, Safety could be decreased. Equipment and chemical services would be at risk. Maybe you have to start switching equipment to alternate sealing devices that don't work as well. If the regulations, the way they're being described in some of these news articles I mentioned earlier, were to be believed. And also, if we don't have PTFE, we're not allowed to use PFAS chemicals, it's going to reduce innovation in technology for both safety and efficiency. So this slide, I think what we want to do is show you a couple applications. You're looking at this plant section right here, very nice and clean. Where would PTFE or fluoroelastomers show up here? Right there, you're going to see a rotary valve, right? That valve has a seal in it, and it also has a seat that the disc sits on. And that's what seals fluid from going from the top part of the pipe, actually upwards in the pipe. So without PTFE, that seal would no longer be available. And if you're pumping say, sulfuric acid at a specific concentration, PTFE is probably the only material that's typically used in those valves because it's resistant to that. We'll look at the next application. So here you're going to have bearing protection in the pump. That may use polymer fluoroelastomer seals to prevent fluid bearing oil from escaping or getting water intrusion into the bearings to protect them. Let's see that next area. And right there is your mechanical seal is in that area where you're compression packing. Those mechanical seals use fluoroelastomers, basically O-rings, to seal between static and dynamic components. And those materials are highly engineered and highly resistant to temperature and all kinds of chemicals. And without those, it could be easily, you can put an elastomer like a normal rubber based, like an APDM, put it in the wrong application, it'll disappear fairly quickly. So the safety factor of having to choose between multiple O-ring materials without being able to use PFAS is going to be a real problem. Now, I love this one because as I was looking at this picture that Desiree sent me, there's PTFE thread sealant on those components right there in that elbow. That creates a nice tight seal between the threads so that whatever's in that pipe or in those fittings doesn't leak to atmosphere. And actually, we've seen studies in emissions that show that a significant amount of leakage can occur from those joints. So using PTFE joint sealant and threaded connections is really important in making sure we have leak-tight systems. Okay. Okay, that right there you'll see is another valve. That's an actuator that's on top of that valve. So they can operate that valve remotely. That actuator right there has seals in it, which could be fluoroelastomer O-rings, could be lip seals, which are made out of fluoropolymers. My point being is you can see all these pieces of equipment. You can't see these perfluorets or PFAS materials at play, but they're everywhere. I mean, you can even see gauge glasses behind them there. They might be lined or coated with PFAS or PTFE type materials. The cabling and the connections to the equipment that house the wires to the motors can have PFAS in them. I mean, again, there's more applications here, but the whole point really is to show you the ubiquitousness of these PFAS chemicals, and particularly PTFE and fluoroelastomers in these applications. And without them, all these applications that are successfully designed and operate and have for years with the ultimate in safety and performance, all this would be compromised if we were not allowed to use this material.
Yeah, I think this is a pretty compelling narrative, just in one glimpse of one sector, if you will, Phil. Thank you for taking us through that. I'm going to ask you to imagine that in this photo now, there is no PTFE or other integral PTFE product that's being used. It's gone. What is the outcome of that from your perspective?
I think there'd be, and I'm just thinking this big picture, but I think there would be so many specific issues. Let's just say, for example, I'll give you an example in a valve. Valves can also be sealed with other materials. For example, graphite is an alternate sealing technology, which is usually used for high temperature applications. Now, graphite can be used at lower temperature, but it's not as compatible with chemicals as PTFE. So there are plenty of applications where you can use PTFE, but you can't use graphite. There are plenty of applications where, the graphite has a higher coefficient of friction. So in other words, what the energy it takes to actually move a component like a valve or a pump shaft if it's packed with a graphite packing is higher. So the energy consumption will go up. Graphites cannot do things that PTFE can. For example, graphite typically doesn't go through thermal cycling well as far as maintain sealability over the long term without being adjusted. PTFE can. So I think the other challenge it might be is if you have to, as a sealing system user or a pump manufacturer rather, has to have alternate materials. There might be 8 different materials you can use for different subsets of applications where PTFE can cover them all. And the problem there is what happens if they're misapplied? Like, for example, you get a seal with an EP O-ring in it, and it goes into a fluid where EP is not compatible because someone didn't know any better. A perfluoro or fluoroelastomer would do much better in those situations because of its capability. So the point being, I think safety would be compromised, performance, emissions rates would go up,
Hey, Phil.
energy consumption would go up, everything would be, I think, disastrous.
Phil, just to add to that, I think maybe let's just say some of the stuff could be changed out or we could switch to something else. Just the time and effort to do like an MOC for all of these changes and then have an engineering to qualify and as you said, triple check to make sure that the chemical compatibility or that the performance, a lot of things with exfoliated graphite, just the way it's installed is differently compared to a PTFE product. So there might be training involved with the new people. Basically, what we're saying here is with just to make a legislative change when for this product that, as we said, has no health related issues compared to PFOA or PFAS, could cause all this extra effort and work for a reason that is not needed.
Yeah, I think it's a good point. It create management change issues with equipment manufacturers, with end users, with sealing device manufacturers, that need to meet the needs of the equipment manufacturers. It would create, I think, a whole lot of chaos, if you ask me, to just simply ban the material.
And once again, we'll talk about it when we get to the next slides. I mean, there are going to be different layers of gray of how this could go, but either way, it's something that we all should have our eyes wide open about the possibilities.
Yep.
Thank you both. Why don't we go on and talk about another widely used and important category of PFAS?
So yeah, I want to just touch base quickly on the fluoroelastomers. The mechanical seal that you saw on the pump that seals the rotating impeller, which provides, that's the key to all pumps, right? Is the impeller, and that seal is to keep the fluid from leaking out of the pump. Fluoroelastomers are a key component. O-rings are in particular used ubiquitously in mechanical seals, and I just want to touch on those basically because fluoroelastomers are a subset of PFAS. They are, they have some elastic properties and other things that make them really perfect as elastomers to be used in O-rings. And the only reason I bring it up is because it kind of is a subset, Desiree, of what you mentioned before. What would be the outcome here? One of my colleagues at FSA basically gave me some numbers on the split between normal elastomers like EP, ethylene propylene O-rings versus fluoroelastomers. And roughly the number of the pumps he gave me in API examples for, oil and gas applications, 86% of those sealing devices, the mechanical seals, use perfluoroelastomers or fluoroelastomers. I keep mixing those two up. I apologize. So the commonly one used there are FKMs, fluoroelastomers, perfluoroelastomers, and FEPM type materials. They're the most common ones. Variations of those elastomers are used, like I said, in 86 and up to 90+% of the mechanical sealing devices out there because they're proven to be a superior elastomer. So their presence in the sealing device market, particularly mechanical seals, which are often and most often used in pumping applications. Packing is used to a lesser degree in the pumps, but the point is it's super important. And if we weren't allowed to use fluoroelastomers in these mechanical seals, Desiree, we'd have a real problem because I think it create wholesale challenges to making sure that these seals can last as long as they do and perform as well as they do in these applications if we were to say that these couldn't be used anymore.
Right. So, we've heard about, the importance from both and Ron of PTFE and or elastomers. We know that there are some outstanding and in many instances irreplaceable products involve the use of those particular PFAS chemicals, and they're widespread, right? And we're reliant on them in many ways. And that grid you showed earlier with like 16 tiles really makes the point of how prevalent they are in our daily lives. And again, many very important sectors and uses. So I'm going to ask you, what's the problem?
So I think what is the real challenge here of what we talk about with legislative, where is the regulatory area going with this? I think we already mentioned that first one, which is this idea of grouping, of people think that, oh, they've heard some horror story about one of these chemicals and then classifying it to just call it PFAS. So, for example, we've seen, talk in the federal laws here in the United States of possibly coming through with something like banning all PFASs, but we've also seen it in the states quite amount. Right now, there's a state law in the state of Massachusetts. In the state of Maine, where there is a law that says they will ban all PFASs, where they're talking about I think it will take effect in a few years, but you would literally have to get you'd have to get some type of paperwork to purchase any PTFE material for gaskets, for O-rings, for anything that is considered a PFAS material. You would need to get it categorized by the state and have to sign something that there's no alternative to use it. So that they're keeping an inventory of all PFASs they would be using. So that would be something we'd be very much against. Banning all products that include PTFE, that include any PFASs. Of course, we would really want to kind of break down, as I said, into each chemical and comparing those as that are considered that need to be taken out of human usage. And as I said, this is going to be a very big issue of where it goes. As Phil mentioned earlier, the FSA, we've been very much concerned about this for the last few years. The Fluid Sealing Association has talked to many people in Congress about legislation that has been proposed on the national level. And it's really good because they all, it's just kind of like a fire hose information coming to these people. And being able to hear some common sense issues about how important PTFE is for our market has really kind of tried to level and balance a lot of the hysteria that's out there. But I'll tell you what is important is that we all be aware of where this is going and making sure our voices are heard. So that's where we're really concerned about, especially I think we're also got to be talking about being advocates for industry here. This could be terrible for manufacturing and for industry here in the United States. If a law like this got passed, it would be a tremendous burden for something with a chemical like PTFE that is not even, being grouped together for no apparent reason, being like this poor baby being thrown out with the bathwater here. So it's very important that we are keeping our eyes open of where this legislation is going and how it will affect industry and all of us.
I think that's right. And Ron, I can't help but go back to your feline analogy and suggest that what we're seeing is that some legislators are essentially saying that there aren't any good felines, and the house cat that you've had for a decade has to go, along with the mountain lion, right? And this sort of overbroad approach can happen in the legislative process and the regulatory process and in the media. And that's why I think, to your point, it's just so important that we educate folks, from legislators to regulators to our business partners, our customers and the public, on what the impacts are of throwing the baby out. The other point that I would underscore that you made is this is not a hypothetical. These sorts of bills or legislative efforts are happening now. Maine is a very good example of how that's recently happened.
Yeah, for sure.
So why don't we go on and talk about the Ceiling Association's view on what approach we could take?
Yeah, I mean, pretty much this is we've actually created a one-page document that kind of goes over all these things, but it's always good to just go over it again. As I said, we believe that all PFAS chemicals are not equal and they should not be regulated as they are. Once again, we're really looking at each chemical compound to be judged itself instead of this mass grouping. And as I said, each PFAS chemical should be treated differently according to its application and toxicity through study and studies on many different pieces there. And once again, we believe that, of course, some regulation is appropriate, and we support that for certain PFAS chemicals. But responsible use of PTFE and other safe PFASs, we think should not be part of this. And as I said, we're also looking at standardized test methods and acceptance limits of materials studied and deemed harmful by the United States Department of, the Environmental Protection Agency, the EPA. And as I said, the umbrella regulations of all PFAS could be the end of non-harmful PTFE and protect our people, the environment, and industrial equipment. It could really hurt if PTFE is grouped into all this. And as we said before, regulation that requires petitioning for all of us for PTFE to impose time and uncertain cost to non-harmful PFAS needs in critical sectors. So totally agree.
So what forgive me, Ron, what I'm hearing is that the Fluid Sealing Association is committed to going about this in a very thoughtful and safe way and looking to regulatory agencies like US EPA to do that, and ultimately being able to keep the kitten, but properly contain the mountain lion. I can't, again, help but keep going back
I love
to
that analogy.
I
love how you like it. It's great. Well, I think that really fits into the Fluid Sealing Association's main charter that we have. I mean, once again, one of our main missions is regarding using safely using sealing products in industry, and we're also very concerned about using these technologies important. So we really think our voice is very important here, and we surely think that with the Hydraulic Institute, they're is kind of seeing how much their eyes are open to how much it could affect pump business with this issue of getting rid of PTFE and other fluoropolymers. Sure.
Agree. Why don't we look to some of the options that our association sees and others are talking about?
I think once again, we're really talking about science, and we understand there's a lot of science that has already been done on certain chemicals. We really are fine about a science-based approach to regulating harmful PFAS chemicals, but making general statements, especially with a product that has been used so much like PTFE, we feel that is a linkage we don't want to make. We want it to be science-based. And once again, we're talking about distinguishing hazardous versus non-hazardous chemicals, not, as I said, just using one name. And as I said, here in Massachusetts, about a year ago, they came out with the PFAS 6 compounds, which really are only 6 of the 4,700. And, to make that jump from a small number to over 4,700, we think is a big jump and is concerning. And we said chemicals that have not been studied or deemed harmful should not be added into any regulation, for sure. And this is one that we're really thinking is to have a carve out for PTFE and fluoroelastomers from federal and state regulations on PFAS. Currently, the laws that are in the state of Maine and laws that have been proposed in the federal government all have giant carve-outs for medical use. We want to know why aren't there the same type of carve-outs for a product like PTFE and fluoroelastomers for industry? We think that's an issue that whenever we bring that up to legislatures, they'll go, "Oh, that's a really good idea," and we're like, yeah. But I think compared to the medical industry, I think they have a larger voice in there, and they get into where the laws are already being written, and we're coming in the back, and it's really important that we have this voice. And I think that's one of the main reasons we wanted to do this webinar today, is for awareness and to get everyone to kind of see what is going on right in front of them before it's regulated out.
Yeah, I think that carve out option is really important, and it's just so well established in the way that laws and regulations and policies have been drafted in all sorts of areas. So this is, to your point, not unique. We've even seen it with the examples you provided, Ron, in the PFAS space, where some narrow exceptions have already been written into the books. And
Right.
so this is an appropriate strategy. And if our legislators and regulators are thoughtfully working through that, we think that a carve out is an appropriate option for thinking about
It
PFAS.
might just, once again, one of the big eye-opening things for myself, and I think Phil would say the same thing, is when we were talking to these legislators, how they didn't know how industry in this country works or how big it is. I've been very fortunate in my career to have been to many of these plants and really see people who get up every day and do and make these materials for large companies here in the United States, and that would be such a burden for them and for that part of all manufacturing here if we lost that ability for this product. And I don't think that they really saw that linkage until we brought it up to them. So a lot of this is, as we said, just bringing this awareness to legislatures and to the differences between PTFE and these other chemicals, I think is very important and one of the main points of this whole thing.
It's that aha moment, isn't it?
Yes.
So why don't we talk about our role? And I think when you all mentioned our role earlier during the agenda slide, we're really talking about all of us, every one of us in this conversation today has some role. So let's turn our attention to what we can be doing.
So my couple things that just to summarize, all the comments that Desiree and Ron had earlier is spot on. I think the key for me is in these discussions is you don't know what people don't know, right? In other words, we've had discussions with some legislators whose staffers were well versed on this issue, and some that were sort of aware of it but didn't know. So the point being, every opportunity we took with our government affairs committee and our colleagues to contact these folks was education is important no matter what. And you, like I said, you got to get your position out there. So we've been doing a lot of that to make sure that we do that. But educating yourself and your peers and customers in your sector, I've talked to some of our valve customers to kind of illustrate, my concerns here and, to make them aware of what's going on, because some people will read this article and not quite get to what that means until they start to see it pop up more. So I think the key is if you have any comments, questions, there's a website link there to the Fluid Sealing Association site. You can also contact direct questions from Hydraulic Institute to Pete at that email address. And I believe the presentation will be distributed afterwards to participants. But the big thing is to communicate the value of PTFE and fluoroelastomers and other fluoropolymers. If it means a lot to your product lines, the systems that you're procuring product to go into, that we communicate that to as many people as you possibly can, and support the HI and FSA on those efforts to make those points known. So real kind of summarized real quick. No two PFAS chemicals are the same. There's 40-something, 4,700, I think Ron said. But, PTFE, certainly in our estimation, is not one of those, but we don't want it to be lumped in there, as Ron already mentioned. There are plenty of safe PFAS chemicals, including PTFE and fluoroelastomers, that are, ubiquitous in our daily lives and essential components. And, we believe that we have to educate as many people about the value of this material. I pushed this one particularly when we did our meetings with the legislators. There are no good substitutes for many important uses of PTFE. There's not one material that can do everything that it can. So again, the image that Ron showed of throwing the baby out with the bathwater, not using PTFE because it's a PFAS is not a good idea. And again, I think all of us and all the participants here, understanding this, that's why you're here, but also learning more and talking to your regulators, legislators, and the general public about the value of the material and its safety, is of utmost importance to us all.
Thanks, Phil. And I would suggest that this is a photo op moment. I would have my smartphone out and take a picture of these 4 bullets that you've shared, Phil. I think they're all really important and sum up, in fact, the key takeaways from today. But I'm hearing educate, educate, educate. That is something certainly we can all be doing. At this point, it is, with your help and instruction today, really hard to imagine a world without PTFE and some other safe PFAS chemicals. So why don't we at this point move on to some questions that folks in the audience may have. Amy, I'm going to ask you to assist us with opening things up to the group.
Sure thing. Just give me a moment, Desiree. I think I need to be the presenter in order to give everybody the opportunity to mute. So if you could stop sharing your screen for just a second. Wonderful. All right, I went through and I changed the settings so that all of the attendees that are on the session have the option to unmute themselves. We have a few minutes for questions. And I want to reiterate what was mentioned earlier, that the recording of this presentation will be made available just as soon as I get the link from WebEx, and I will distribute that along with the PowerPoint of today's presentation and as a PDF file. There were a couple people who were asking about it, so I will be sending that out probably first thing tomorrow morning.
Yeah, we did get a question in about the ES. It says EAS. I'm not sure if you're talking about the ESA, the European Sealing Association, Rob, but we are working very closely with the European Sealing Association. They are also are working on trying to see what legislation is going through in the European area. So I think that's where you're asking, Rob. But yes, we're working very closely with them. I think that's the only question.
I have a general question about the act right now for PFAS regulations. I know they're talking about it federally, and some things are coming out on the state level. What's the current landscape as far as what manufacturers need to kind of be aware of? Is there some kind of picture of that?
It's really kind of hard to, in my opinion, I think it's going to be kind of hard to see it from the people we know in DC. Is it looks like it doesn't, that there are a lot of this is being put on the EPA to come back, and they're still looking at studies in that regard. We don't know about the laws that have been proposed on the federal level have kind of been shelved. It looks like it doesn't look like it's going to be going right now. Our biggest concern is more state laws, like the Maine law spreading. But then again, Maine is also starting to realize that they might have bitten off more than they put in the original legislation. So there's a lot of things changing. What my worry is there's just such a wave of discussion. Just to bring up one more point, a lot of this is dealing with the water testing piece. There are a lot of people being able to test for certain of these chemicals in water to very, very low levels. And it's being noticed a lot more because people are getting these new pieces of equipment to test at those levels. So I think that's going to be a main issue. It's just really about which PFAS chemicals that they're testing for. I think that's our biggest issue.
Yeah, I would say to add to that, Ron, the legislative side and the federal is is slowed. So it kind of goes on pause while other things take precedence right now with the federal government. And your point about this state of Maine is excellent because other states, I think, have looked at that legislation, but then might go pause or are doing some more longer term studies once they see the complications that come when Maine looks to implement and realizes, oh, this is extremely costly. And then they start to find out, oh, we got to regulate this material. This is what it's going to cause, right? I don't think people have a clear sense at the government level, state or federal, more so maybe at the federal, with the EPA kind of being more versed in the subject, but that what the implications are with what you say when you write a regulation or some legislation.
There are,
Go ahead.
excuse me, Ron. There are a handful of questions in the chat, but we are at 2 p.m. Eastern. I can copy the questions that are outstanding and distribute them to the presenters and Desiree for consideration. If that is all right, just being mindful.
Absolutely.
Okay. All right. So on behalf of HI, I would like to thank everybody for attending today's session and extend a special thank you to Ron, Phil, and Desiree for taking time out of their day to share their knowledge on this topic. Once again, the recording for today's presentation and the PowerPoint as a PDF file will be available by tomorrow morning, so be on the lookout for that. I will put my email in the chat box. If anybody has any questions, you can email me directly.
Perfect.
Wonderful. Thank you very much, everyone.
Thanks, everyone.